Hi folks, welcome to part 3 of this Mondeo running rough video, and I've had to come to a decision and a conclusion to move things on. Let me show you what I've had to do now. This problem is a problem which I'm going to have to deal with, or I will have to give someone else the job of doing, where it's out of my control and it's going to cost me money. So me being the sort of person that I am and coming from a background of a diagnostic sort of background when I was an electrical engineer, and I've worked on many different issues of building services, maintenance, control panels, all sorts of things. Massive panels, relays, semiconductors, solid state relays, switches, vacuum hoses. I've dealt with so many different things, and in a way these things I used to have to go through fault diagnosis procedures, very much with as you would do normally with a car when I used to work on cars years ago, and only for a hobby, mind you, not as a profession, where I would be able to tune a car up using data, for example, out of a manual, for example, which we used to all have. And in there you could get things like ignition timing, you can get carburetor settings and stuff like that. Any mechanical job you could actually tackle to make the engine run to its optimum performance. You was given a set of specifications, which is in the manual, and you could then diagnose a problem and then tune the car accordingly. And that's the way things used to be. Well, on these type of cars now, as you know, they are computer controlled, and they rely on input of data from various sensors all over the car, not just for the engine management, but for things like the braking systems, the air conditioning systems, the cooling systems. The list goes on and on. And as a result of this, you've still got what you had before, which are indicators in the car telling you of certain criteria, like temperature gauges, for example, oil pressure gauges, stuff like that, or voltmeters, stuff where you can actually physically look at and see at first hand what's actually going on. But them sort of things now tend to be hidden in most modern cars. A lot of cars you don't see a temperature gauge or an oil pressure gauge, for example. What you normally get is what you call a warning light come up, or an idiot light, as you used to call them. In other words, a light will come up when a set of conditions has been altered or deviated from according to the accepted norm, and as a result of that you then have to diagnose a problem. Now, where me and you used to be able to diagnose a problem by going to the manual, looking at the specifications and then seeing if any variance of the specifications has been breached, and then you can repair the job. Today's cars have got electronic brains being fed information via different sensors all over the place, and as a result for that, the job of taking a car's information via an indicator light has been changed, where you now have to plug in one of these or a diagnostic tool to one, retrieve the information, and two, to actually monitor what the car is doing via the different sensors. That can throw up a fault code, and a fault code gives you an idea of where the possible fault may lie, or it will give you a pointer as to why a sensor's acting the way it is. And the way you diagnose all these sensors is an art which I don't personally have, and it's a learning curve now which I'm going to have to probably put myself on because of my diagnostic background and the way that I've dealt with things before. Sure, you can have people come up in the comments section and say, oh, that'll be the MAP sensor, that'll be the mass airflow sensor, that could be a CO2 issue, that could be a leaking diesel pump, that could be a diesel pump, that could be a lift pump, that could be a leaking injector, that could be injectors playing up, one's over fuel or stuff like that. There's all these different variables, but with all due respect, I know that you may have had them problems, the people who have been leaving comments, but at the end of the day, each specific problem with each car is unique to that vehicle. And the idea is that I've now got to find the problem of the car, and just changing parts isn't the way to do it. Although the parts I have changed, for example, the split hose, which did need changing, that would have caused that did cause a problem, and I've now corrected that. The fuel pump, which is a maintenance issue possibly, it was a low-cost item, so I did change that as well. From here onwards, actually diagnosing what the engine's going to be doing under normal conditions and fault conditions needs to be graphed, and you need to see what you call live data, and you can only see that by plugging in a laptop or a diagnostic tool to tell you what every sensor's doing, and then you have to use your skill of diagnosis in interpreting the information to try to come to the conclusion. Now all that can happen without actually lifting the bonnet, by just reading data off of the laptop and the software to actually diagnose a problem, which is what I'm going to have to do. Now this is going to be a learning curve for me because I've never used this equipment before. So there's two learning curves. One is learning how to use the equipment or the software, and two, how to interpret the software into each different condition that they could throw up. There's so many different things, but you can only know once you understand what each of the different sensors do and are they working within their correct parameters. So this is a really big learning curve. This is something which is probably beyond a normal do-it-yourself mechanic unless you are familiar with diagnostic equipment. I'm not, I've never really used it before, not in this field. I've used a multimeter in my trade as an electrician. You can check each individual component with a multimeter to a certain extent by registering its voltage and its resistance. So I could do that if I wanted to, but I'd be guessing my way through the procedure. By using the laptop, by using the proper diagnostic equipment, I'm hoping to come to the conclusion of being able to interpret that information to find out what my problem is. So first of all, let me show you what I've actually brought. It's not, diagnostic equipment ranges from a few pounds up to thousands of pounds. So I've only come in with an entry-level piece of kit after looking online and finding out what other people have possibly been using. And what I've chosen is a piece of kit that you buy. I got this off eBay. It's what you call an OBD2 checker, and this one is the, as you can see, the Ford Super F Super 2 Mark II interface cable, which plugs into your diagnostic socket and then obviously into your laptop. Now someone did make the comment, and I forgot to mention that I did actually have one of these ones, which you've probably seen before, and this is the MMXVII OBD2 reader, which is the one that I've had, and I forgot that I had actually, to be honest with you. And I did actually plug this one into my diagnostic socket, and I've used this before in the Vauxhall, the Vauxhall Astra, as you probably remember, and a couple of other cars, I can't remember. But apparently for the early Mondeos like this one, for some reason this comes up with a link error, so I wasn't able to get any data or fault codes off of this at all. So that's the reason why I had to move on to another one, and I found that Ford one there, as I said to you. So this one, this will probably work for the TDCI ones, but not the TDDI. And I've actually looked in the forums, and other people have had that problem as well. So this one, if you're thinking about getting a scanner to read your fault codes or whatever, this didn't have one. Right, let's put that to the side. So this item comes with the software disc with it, and apparently the early ones of these, not the Mark II, this one, as I said to you, is the Mark II version. This one has got updated software because, again, same sort of thing. There was problems with people installing the software onto their laptops and reading the earlier Mondeos like this one, for example. So if you're going to get one of these, get the Mark II version. That's the one to have. So I'm going to plug this in now. Again, I looked on YouTube for tutorials on how to use this, as I say, because it only comes with an installation disc for the drivers and stuff like that. So let's plug this in. One thing I will say is that this is a Windows 8 laptop, and when I put the software, it loaded the software in from the disk first of all, and then plugged this in, it wouldn't recognise it for when I got the software up. What I had to do was to go to the device manager in your computer control panel, and then find the actual warning triangle next to the piece of hardware plugged in, right click on it and then say update driver, and it went online and it automatically updated the driver, then it started working. So let's have a look now. Let's plug this in, and we're going to take it for a drive round, and we can do what you call live data on this, where we can record exactly what's going on, choose what sensors we want to record, and then we'll go for a drive and take it for a drive. So let's go and have a go at that now. Right, okay, so I've plugged it in. I've got my laptop here, so I'm just going to go over and fire the software up, which is called ForScan software. So let's just click on that. and it says I'm not connected at the bottom here now, so there's a connect button at the bottom there which you have to click on. So you need the ignition on for that and the unit plugged into the car. So my ignition is on, although we don't want the car started up, and I'm going to click on the connect, click OK. And it's going through some checks now. It's establishing that the connectors, I've already stored my car details in there. It found my car's profile because I plugged it in yesterday. So I'm going to load that car's profiles up, which is my car. And then it goes through a load of logs there, as you can see. It's doing loads of checks there. And it's saying that the logger's registered a DTC, which is a fault. Read the DTC code. So this is the DTC code. So I'm going to go to there. And these are your error codes here, your P codes down there. So it's got one there which it says these are in the last as they come in sort of thing. So the top one is the last one. So the PCM P100, it's saying it's a code P100, which is a mass airflow sensor code. And then it gives you some information. And what it's actually saying there, it's actually saying that the MAF sensor is out of self-test range, which is interesting. And then it's telling you what it does. The PCM tests the MAF sensor during the self-test by measuring the voltage level present at the input to the PCM. And it tells you then what it could be caused by. And it says kinked, blocked, crushed or damaged hose. Now that is interesting, as you know, because we did have a kinked hose. Although a fault light never came up, I think if I would have drove the car for a longer period of time, the fault code would have come up, because it needs to occur a few times, like in other words, to reach a trigger value before it actually illuminates the light. As soon as it actually had the fault, I sort of returned to base, so to speak. So that was that one. And if I go to the P148 code, which is the one below it, again it's saying now fuel delivery error reported. And it says that this fault code may be caused by supply voltage, or when the supply voltage to the FIP, whatever that is out of range. So there's that one. And the one below it, fuel timing error fault. Again, it says something about it could be caused by supply voltage. And then below that, a PCM P1564. And then it's saying that reduce fueling mode. Whether that's limp mode or I don't know. But again, no warning lights have been up while all these codes have been recorded. And I don't know how far back they actually go. Now that one, the ABS code which I've got up there. Now this is one I do know about that, and it's actually told me the rear right wheel speed sensor input signal missing. Now this, my ABS light comes up every now and again. Now that is basically due to my rear right wheel sensor. The little clip that holds the lug on is actually a bit faulty on there. So that proves that that's right and that's working correctly. I do know about that, and that's not a problem. So our main concern is, what I'm possibly going to do is to wipe all these codes off and then start afresh on a test drive, because I don't know how far these codes go back. So I'm just going to go to reset DTC, all the DTCs there, and it's coming back now that there are no error codes found. So we're going to take the car for a drive now, and we've got a fresh thing, and we're hoping to get our fault and capture our fault. And what we do then is, if we go to this graph feature here, this is the PID data, and if we go to the oscilloscope, I want to go to the set up all gauges function down there, and here is a list of all the sensors which my car has actually got, and you can choose the sensors which you want to appear on the graph. So as you can see at the moment, I've chose the MAF sensor, the mass airflow sensor. I've also chose the MAP sensor, the manifold absolute pressure voltage sensor, and the MMXVII, whatever that means. So I'm going to choose a few sensors out of here and put them on there, and then do a live run. I'll see you in a minute. I'm just going to set this up to what I think I need, and then we'll take a look at it. Right, so I've just set up a few things there. MAF sensor, MAP sensor. And let's start the car up, and let's see what happens when it starts to register the software. I've just started the car up now, and I'm just going to hit the record button, or the play button at the bottom. And we should start recording what's actually happening with them sensors in the car. As you can see, I've just revved the engine there. Can you see that? and it's recording different sensors and what they're actually doing. So I'm going to drive along now for a bit, and we'll try and locate that fault on the same route that we went before, and then we'll try and see what this thing is actually reading. Right, okay. So what we know is we've cleared all the fault codes what I've had on there before, and we're now dealing with a clean sheet, so to speak. So let's take it for our little test drive and hopefully recreate that fault what we had. And let's see if we can then, that's not all, as I say, all that's going to do is to record, out of all the sensors that are on there, that's only going to record on that graph the sensors that I've chosen, because there's loads and loads of them you can put on that graph, and that's the choice you have to make, and that's where knowing your diagnostic skills comes in. Right, so at the moment, clean through the rev range, and I can see the graph actually moving up live now. So yep, no problem whatsoever. So this is a whole new concept for me. As I say, I can't just go around just changing bits until we find the problem, because we may not find the problem doing it that way, and that's not really the way to do fault diagnosis. I'm used to looking at a set of conditions, as I used to in my job of work, and then come to a conclusion on the evidence that's been presented. As I say, the mixture of the computer tries to tell the car to run at a certain metered fuel level, which is what they call the stoichiometric value. Apparently, I've only just found this out, and that is 14.7 to 1 fuel to air ratio. And your computer, depending on what the sensors tell it, always will adjust and try to achieve that. Now, as it used to be with older cars, you wouldn't know that if you had a split-in hose on the air intake, for example. Your car wouldn't know that, and the only issue you will know is that it might start to get a bit hotter, and you could, because you'll be having a lean mixture, and you would only know that when you come to service the car, or someone went to tune it up, and you'd know that by doing what you used to do, take a spark plug out and put a colour tune in, which is where you can actually see the colour of the flame, and you could determine a weak mixture by the colour of the flame. That's what I used to do years ago, and then you can get the right mixture. Well, that's more accurate now, where they've got this stoichiometric measure of 14.7 to 1 fuel to air ratio, which your car tries to do all the time to try and achieve that. And it goes by what the sensors are telling it to always try to achieve that. So just because the MAF air sensor might come up as it's registering a fault, you've got to then decide whether it's the sensor that's the fault, or a set of conditions leading the sensor to go out of range, which will cause something else to overcompensate to re-achieve that stoichiometric value of 14.7 to 1 fuel ratio. So you could get a lean condition, your computer would try to make the mixture richer, and that would show up in another sensor. Right, we're coming up to that point now where we started to get the trouble, so bear with me. Again, everything seems to be the same as before, and it's when I pulled out of here that we started to get the trouble. So here we go. And I floored it. There was a bit of a hesitation. Nothing. Nothing yet. Nothing yet. Let's keep going round. I'm in an overrun at the moment, so I can't really tell what the throttle's doing. So, and also I didn't realise that this said there's the mass airflow sensor, the MAF sensor, and there's also a MAP sensor on this as well, which I didn't know. Right, well I'm actually going down a bit further now. Right, so let's go up this road. I'm actually further now than where we went before. So let's go around here. There was a little hiccup there, but I did floor it. So let's again get a bit of speed up. Hold on. Slow right down to a standstill virtually. And then let's try give it a bit of acceleration. Oh, there we go. We had a couple of jolts there. I'm just going to go up to the top again. And again, I'm carrying on driving because I want to see if we generate a fault code, you see. And one jolt may not generate a fault code, but you have to have like not a succession, but a few things happen before it will register a fault code. So I just want to see if I can meet that criteria. Now, yep, it's doing it now, look. I'm keeping it throttled on. Right, that's it, that's enough I think. That must have generated a fault code now. Although there's no warning light up, you see, so it'll be interesting. Yeah. Yeah, there we go, we're not right. Right. And yet, it'll tick over fine. Now that could be, as I say, many things. But all the time, the car's trying to achieve that stoichiometric fuel mixture. So the car's ticking over a treat. Right, so there we go. Bring it to a standstill. Right, okay then. I don't really know how to interpret the data yet, but what I've actually done is pull up my latest fault codes, and as you can see, I've got what you call a P0148, a P0149, and a P0154, and obviously the ABS one, which come up before, which we know exactly what that one is. So this is what we need to concentrate on. This looks like it's where the possible problem could lie, and it says that the P0148 is a fuel delivery error reported by the FIP. And if I just go to FIP, it says that's the fuel injection pump. And it says this may be caused by fuel injection pump supply voltage, where the supply voltage to the fuel injection pump is out of range. So that's one possible issue. And then if we tie that into our next fault code, which is 0149, again, fuel timing error reported by the fuel injection pump. And then it says CPS circuit fault. What's CPS mean? Crankshaft position sensor circuit fault. So that's interesting. So it's now pointing to possibly a crankshaft position sensor. And again, but it says this fault may be caused by a fuel injection pump supply voltage. And if we go to the last fault code, which is a P1564, fuel injection pump requested reduced fueling mode. The fuel injection pump has identified a fault that may cause damage to the engine. So basically, these fault codes that have arisen comes from the fueling, to my way of thinking, possibly due to the fuel injection pump voltage, or where the fuel injection pump gets its reading from the crank position sensor. So this is all new to me. I'm going to have to interpret this information now. To say it's a big learning curve. Maybe you can help with the comment section below, and if you can, give us what you think these are. No guessing, obviously, because it's not about guessing this. This is interpretation of the results, what we found so far. Those are the fault codes which we found after we've reset everything. Those have just occurred, and that's where we need to be checking. So I'll see you in the next video when hopefully we've got more information about solving this problem. So I'll see you then. Bye for now. Peace.